Okay, for solution stoichiometry, do not use the dilution formula M1V1 equals M2V2. That actually would work if it's a one-to-one coefficient, but most of your problems are not going to be that way. Now, I am going to show you the stoichiometry with a lot of one-to-ones, but you will not have a lot of one-to-ones on worksheets, so do the process the way that I'm showing you to do it. First of all, you're going to start with a balanced equation, and so here you're taking silver nitrate and sodium chloride. You're going to do a double displacement reaction, make silver chloride precipitate and sodium nitrate. Okay, now this does happen to be a one-to-one relationship, but again, the process is what's important. All right, I would always write down exactly what you need. It says calculate the mass, grams, of solid NaCl that must be added to 1.50 of silver nitrate, and the silver nitrate is 0.100 molar. Always start all of these with the thing you have the two pieces of information, and the very first thing you want to do is change that big M to moles per liter, which hopefully then will lead you to multiply by liters so that liters cancels with liters. All right, so you should get 0.15 moles of AgNO3. Now the next step is super important. You're going to have to look at these coefficients and do the stoichiometry, and you absolutely need to show that stoichiometry. Do not take shortcuts. 1 NaCl. All right, so we're running out of space here, so I'm going to erase it, but as you see, you're going to do a 0.15 moles times 1 mole divided by 1 mole. But now what's happened is moles of AgNO3 have canceled, and you're left with moles of NaCl. All right, so those first two steps are going to be the same with all solution stoichiometry problems. Now, we are being left with moles of sodium hydroxide, sodium chloride. So you have 0.15 moles of NaCl after we've done the stoichiometry. Now in this case, they just want grams. This last step will be different in every problem that we do together here. And a mole of that is 40 grams? No, 58 grams. Sorry. 58 grams. So 1 Na and a Cl, we should do 0.87 grams. Or 8.7 grams, sorry, 8.7 grams. And that will be how much NaCl is required. If we dump 8.7 grams into this solution, 1.5 liters of this concentration, it should go to completion. We should get AgCl. Now to calculate the mass of AgCl, we simply go back to the 0.15 moles of AgNO3. 1 mole of that will make 1 mole of AgCl. Once we have moles of AgCl, we can figure out what the molar mass of AgCl is and convert it. And I did not calculate. Okay, we're actually going to skip. We're going to go to a neutralization reaction. And this is where the M1V1 equals M2V2 might be tempting, but don't use it because you're not going to have one-to-one relationships. So we're going to take an acid, which is HCl or HNO3. We're going to take a base, which is KOH or NaOH. We're going to put them together and make a salt and water. So we're going to take hydrochloric acid, sodium hydroxide. This is a double displacement where we're going to get water and a salt, HOH. Okay, so it says what volume of a 0.1 molar solution is needed to neutralize 25 milliliters of a 0.350 molar solution. Okay, definitely write everything underneath that you need. Start with those two things right there. And again, if you do that, change this big M to moles per liter, you're going to get 0.35 moles per liter times, I'll make sure you change that to liters, 0.025 liters. Liters will cancel, and you will get moles. And moles here would be 0.00875 moles of NaOH. The second step is going to be the same for everyone. Like I said, you're going to go up here to the balanced equation, and this one does happen to be a 1-to-1, but you know, if this happened to be a 1-to-3 or a 1-to-2, you just follow stoichiometry like you normally do. So 1 mole of NaOH, 1 mole of HCl. So we're going to multiply this by 1, divide it by 1. Obviously, the numbers aren't going to change. But what has changed is the fact that we are now have stoichiometrically jumped from NaOH to HCl. So now what we can say is that we have 0.00875 moles of HCl. Now, the question is how many liters or mils? It didn't really say mils or liters. But notice what we have. We have another piece of information. Now, some people are going to want to set up a ratio, and that's fine. But what I'm going to do with this 0.1 molar, remember what that means. That means 0.1 moles per 1 liter. I'm going to flip it. I'm going to use the 0.1 mole down here and the 1 liter up here. Moles will cancel, and 0.0875 liters. This is supposed to be a 5. Liters of HCl, of that concentration, or 87.5 mils. Now some people are going to want to set up a ratio. They're going to want to say this many moles over X liters equals 0.1 moles over 1 liter, and you're going to cross multiply and you're going to divide, and ultimately all you're going to do is divide by 0.1. So I'm just saving you all the time. This last one is going to be super important because it's going to be what we're going to do in lab. So I'm going to actually do it on this page where there's a little bit of room. We're going to put the base here in the burette. We'll put our acid here. And in this particular problem, the acid HCl and sodium hydroxide will get neutralized. And what we said is there's 15 mils of acid in here, 15 mils of that. To neutralize, we're going to add that base, and we're told that it's going to take 52 mils of that base. We're also told up there that we have a 0.34 molar solution, if you read the problem carefully. So this is for sodium hydroxide. So we're going to take that information. We're going to take 0.34 moles per liter. We're going to multiply by 0.052 liters. And we're going to get 0.0177 moles NaOH. We're going to then do stoichiometry. This does happen to be a 1-to-1. Again, though, if this were like a 2-to-1, just go for it. Okay, it happens to be a 1-to-1. So 1 mole NaOH to 1 mole HCl, we will get 0.0177 moles HCl. Now, we are looking, if you read the problem, we are looking for the concentration of HCl, and that's what you're going to be looking for as well. So what we're going to do is we're going to take these moles, we're going to take 15 mils, we're going to change that to liters, we're going to put the two pieces of information together, and we're going to determine that this is 1.18 molar HCl that we put into this flask. So definitely have this down. It's going to be used in lab.